Welcome to part 2 of the series and sequences video series. In the last video, we covered arithmetic series. Today, we're going to be looking at geometric series. So what is a geometric series? Let's say I started off with $100 and I had a goal of doubling my money every single day. What would that look like? So let's say I started with $100, I then doubled it the next day to $200, doubled it again to $400, $800, and so on. By day 5, I would have $1,600. In this sequence, every term is double of the previous term. So to go from 100 to 200, I needed to multiply by 2. To go from term 200 to 400, I again multiplied by 2. And the same pattern happened where I multiplied by 2 to get from one term to the next. So this is a little bit different to an arithmetic sequence. In an arithmetic sequence, we had a common difference. We were adding the same difference to each term every time. In a geometric sequence, we're multiplying by what we call a common ratio. So the common ratio, mathematically, we represent that by the letter R. And the formula for that is just going to equal T2 divided by T1. So one term divided by its previous term. Looking at this sequence, it's going to be the term 2 is 200 divided by term 1 is 100. Crossing that out, we just get 2. So the common ratio is 2. And we can see that. The common ratio for each term is 2. Now again, remember, we don't just have to use the first two terms. It's the same thing as if I did the fifth term divided by the previous term, which is the fourth term. That is going to equal 1,600 divided by 800. Which again is just equal to 2. So the common ratio is 2. So how do we use this to then find any term in a geometric series? So the formula for the nth term is going to equal, well, we're always going to start with our first term. Our first term is a, and then we're multiplying by the ratio every time. So multiplying by the ratio to the power of n minus 1. And that's because if we want the third term, we need to multiply by the ratio twice. So let's do that. Let's try and find the 10th term. How much money do I make on the 10th day of this geometric series? So the 10th term is going to equal the first term, a, 100, multiplied by my common ratio. We know my ratio is 2 to the power of, again, I want n is equal to 10 minus 1. That equals 100 times by 2 to the power of 9. That's just going to give me $51,200. That is the 10th term in this geometric sequence. So this is an important formula for us to learn. Again, Year 12 Mathematics Advanced students, this formula is on your formula sheet. But like I said, it's great to just learn that so you're not flicking through that formula sheet. Now that we know how to find a term within a geometric sequence, let's look at finding the sum. So the formula for the sum is the sum of n terms is going to equal the first term a, multiplied by r to the power of n minus 1 over r minus 1. So let's sub in everything that we have. We know from this geometric sequence that a, the first term, is equal to 100, and we calculated earlier that the ratio was equal to 2. So the sum of the first 5 terms, S5, the sum of 5 terms, is equal to a multiplied by r to the power of n, so 2 to the power of 5 terms, minus 1 over the ratio of 2 minus 1. Siri, what's 2 to the power of 5?
It's 32.
Simplifying this, we get 100 multiplied by 32 minus 1 is 31 over 1, which just equals 3,100. So the sum of the first 5 terms of this geometric sequence is 3,100. So this is an important formula to memorize. It's the formula for finding the sum. And Year 12 Advanced students, again, this is on your formula sheet. Now that we've learned the two formulas relating to geometric series and sequences, let's bring it all together in a question. So we're looking at this series, 5 minus 15 plus 45 minus a whole bunch of numbers in between. And then the last term is going to be negative 10,935. And we're asked to find the sum of this geometric series. So we know the formula is Sn equals all of this, but we don't know what n is. We can figure out a and we can figure out r, but we don't know how many terms are sitting in between this dot, dot, dot. There's a whole bunch of terms. So the first thing we're going to do is we're going to back solve using the formula to find a specific term to solve for n. So the formula we're using is Tn equals a r to the power of n minus 1. Using this formula, we can sub in our last term, so minus 10,935 is equal to a, which is going to be our first term, 5. Now, what's our ratio? Really quick, our ratio is t2 over t1, which is the second term, minus 15 over the first term, 5, which gives us negative 3. Again, you don't have to use the first two terms, you can use any two terms. If we did 45 divided by minus 15, we're still going to get minus 3. So it's the first term multiplied by minus 3 to the power of n minus 1. All right, I'm solving for n, so the first thing to do is get rid of this 5. Dividing both sides by 5, we get negative 2,187 is equal to negative 3 to the power of n minus 1. Now, because n is going to be a whole number, an integer, we're not going to get an irrational solution. There has to be a perfectly rational solution. So in our calculator, if we do a bit of guess and check, we can see that 3 to the power of 7, or negative 3 to the power of 7, sorry, is going to equal negative 2187. So negative 3 to the power of 7 is equal to 2187. So we can simplify it like that, and that's just going to equal negative 3 to the power of n minus 1. Again, this is going to work every time because n is going to be a whole number. It's an integer. It's a place. It's going to be the nth term in this geometric series. So continuing from here, because both have the same base of negative 3, we can say 7 equals n minus 1. So n is going to equal to 8. This term is the 8th term. There are 8 terms in our geometric series. Now that we've solved that, we can sub that back into the sum formula and solve for our sum. Okay, so we had n is equal to 8. Now our formula, the sum is going to equal the first term multiplied by Rn to the Rn minus 1 over R minus 1. So subbing in everything that we have, the sum of the 8 terms of this geometric series is equal to the first term, 5, multiplied by R, which we know is negative 3, 8 to the power of 8, as there are 8 terms, minus 1 over R minus 1 is going to be minus 3 minus 1. So simplifying from there, that is 5. Negative 3 to the power of 8 is 6,561 minus 1 over minus 3 minus 4. Minus 3 minus 1 is minus 4. Simplifying from there, minus 1 just gives us 6,560 multiplied by 5 is going to be 32,800 divided by negative 4, and simplifying that, we just get minus 8,200. That is the sum of this geometric series. Now that we've learned everything for geometric series and sequences, let's bring it all together with a 2-mark question from a Year 12 HSC trial paper. So we're told that the 4th term of a geometric series with common ratio minus 0.9 is negative 21,141. So they're being really nice. They've already told us it's a geometric series. We've got the common ratio, but we only have T4. We know that T4 is equal to minus 21141. We're asked to find the sum of the first 18 terms of the geometric series. However, we don't know what the first term is. If we look at the formula that we're going to be using, A is one of the requirements, but we don't know what A is. We're now going to solve for A. We're going to back solve using the Tn formula, this formula up here. So minus 21141, the 4th term, is going to equal A multiplied by the common ratio of minus 0.9 to the power of n, which is 4, minus 1. So dividing everything by this, minus 0.9 to the power of 3, dividing minus 0.9 to the power of 3 on both sides, it's just going to cancel, and A is equal to minus 21141 over minus 0.9 to the power of 3. And when we put that into our calculator, we get the first term, A, is equal to 29,000. Now that we know that term, we can sub that back into the sum formula. So we solved A is 29,000. Now to find the sum of the first 18 terms, we sub into the formula. So the sum of 18 terms is equal to A, which we have just solved is 29,000, multiplied by my ratio of minus 0.9. R to the power of n is 18 terms, minus 1 over R minus 1 is minus 0.9 minus 1. There's nothing else to really simplify here, so we can put all of this straight into our calculator, and we get the sum is equal to 12,972.2, correct, to 1 decimal place. And that's it. This was a 2-mark question from a Year 12 Math Advanced Trials paper. The last part of geometric series is what we call the limiting sum of a geometric series. Now, what does that mean? Let's say I had a particular sequence where the first term was the number 1. Every day after that, the number halves. So the day after that, it would be a half, then it would be a quarter, after that it would be 1/8, and after that it would be 1/16. Every day my term is halving, so I multiply by a half. So I can obviously see here that my ratio is less than 1. My ratio is a half. When we have ratios where the absolute value of that ratio is less than 1, we have what we call a limiting sum. That is because if we were to add these numbers together up until infinity, eventually they would converge a specific number. If you think about it, on a number line, this is the number 1, this is the number 2. And I was to add all these numbers together. On the first day, I would have exactly 1. On the next day, I would add a half. Then I would add a quarter. Then I would add an eighth. Then I would add 1/16. Eventually, if we were to zoom into this interval and expand, we would just be adding a half of the previous days. We get closer and closer and closer to the number 2, but we never actually get there. We approach it. So we have a specific formula for this. We call this the sum unto infinity, because even if we had infinity terms here, we would have 1/32, 1/64. The term is getting smaller and smaller and smaller, so we never actually get to that number. The formula is just equal to the first term over 1 minus r. So in this, if we were to apply this formula to this geometric sequence, and we were to add every term up until infinity, we can see my first term a is equal to 1, and we know that my ratio we solved before is equal to a half. Subbing that in, it's 1 over 1 minus a half, that is equal to 1 over a half, which is just equal to 2. And as you can see diagrammatically, we approach, but we never actually reach the number 2. Now that we know the limiting sum of a geometric series, let's do a 2-mark HSC Math Advanced trial question. So an object rolls 0.5 meters in the first second. Each second after that, it rolls by 2/3 of the previous roll. How far will it roll altogether eventually? So we know our first term is 0.5 meters. We then have a ratio, the common ratio is equal to 2/3. It is 2/3 of the previous roll. All we do, we sub this into our formula. So the sum to infinity is going to equal 0.5 over 1 minus 2/3. And in our calculator, that just equals 1.5 meters. That's the limiting sum of this series. That brings us to an end of the entire topic, series and sequences for Year 12 Mathematics Advanced. This is a topic that would normally take you anywhere from 4 to 5 weeks to learn in class. You've learned it in just 2 videos. Please let me know in the comment section what you would like to see in upcoming videos, and check out the playlist for more math videos.